Welcome to the Explainer. Ever wonder how a machine learns that a single word can change its entire meaning just based on the words around it? Well, today we're diving into the model that really cracked that puzzle, the Conditional Random Field, or CRF. All right, to really get what makes this model so special, let's start with a quick challenge for you. Take a look at the next word I'm going to show you. Is it a noun or is it a verb? Yeah, it's impossible to know for sure, right? I mean, in the sentence, I will book a flight, it's clearly a verb. But in I will read a book, it's a noun. The word's whole identity is completely defined by the context around it. And this is the exact problem that a lot of basic machine learning models run into. They look at data points one by one, totally in isolation, and they're forced to make what's basically a 50-50 guess. But a smarter model, well, it can look at the surrounding words and make a much more informed decision. So, what this highlights is a really fundamental problem. See, making predictions without context is kind of like trying to solve a jigsaw puzzle, but only being allowed to look at one piece at a time, completely ignoring how they all connect. You just lose so much valuable information that way. So what if a model could look at the entire puzzle all at once? Well, that's precisely the idea behind our hero model for today, the conditional random field. A conditional random field is built for exactly this. Instead of making these isolated guesses, it treats the entire sentence as a single connected problem. It weighs all the possibilities at once to find the most probable set of labels for the whole sequence. And the source material really puts it perfectly. The secret sauce here is the graphical model, which honestly is just a fancy way of saying it builds a map that connects the dots between data points. It recognizes that each prediction depends on its neighbors. Now, the most common type of CRF, the linear chain model, sees a sentence exactly like this visual, as a chain. Each word's label, like noun or verb, is a link. The model learns these simple rules, like knowing that an article, say is probably followed by a noun, not another verb. And here's the crucial part. It finds the strongest possible sequence for the entire chain, not just the best guess for one single link. So this ability to understand context isn't just some neat academic trick. No, it's a genuine superpower that's used across a ton of fields in modern tech and science. And the versatility here is incredible. In language, CRFs help your phone tag parts of speech. Then you jump over to biology and they're doing basically the same thing, but for sequences in our DNA. And in computer vision, they can label a cluster of pixels as a car because, well, it's connected to another cluster of pixels that looks like a wheel. In every single case, the principle is the same. The label of one thing is heavily influenced by its neighbors. To really truly appreciate what makes CRFs so special, it really helps to compare them to an older and maybe conceptually simpler relative, the hidden Markov model, or HMM. Okay, so the core difference, and this is key, lies in their whole approach. HMMs are generative. Think of them like a storyteller trying to create a believable sentence from scratch, one word at a time. CRFs, on the other hand, are discriminative. They're more like a detective. They look at the entire completed sentence, all the evidence, and then decide on the most likely role each word plays. And that detective approach makes CRFs way more flexible, since they can use any feature from the entire sequence to make their final judgment. But, the story doesn't just stop with the basic linear chain model. Oh no. Researchers have taken this core CRF concept and just run with it, pushing it even further to handle much more complex relationships and data. These advanced versions are really fascinating. You've got higher-order CRFs that expand the context, looking back several steps in the chain, not just one. Then there are semi-Markov CRFs, which can label entire chunks at once, like recognizing John Fitzgerald Kennedy as a single entity. And then you get latent dynamic CRFs, which act like these super detectives, uncovering hidden patterns in the data that aren't at all obvious to a human eye. So the big takeaway here is pretty clear. Context is everything. Whether we're talking about language, biology, or vision, the individual pieces only make sense when you see how they all connect. CRFs give machines this powerful framework to stop seeing a boring list of facts and start actually understanding the story. And that leaves us with a final, pretty provocative thought to ponder. If a machine can truly understand the story, and not just the words, what comes next? Thanks for joining this explainer.